Thanks for joining me. We're going to hit density today. It's our concept we're going over. Just do some basics, just kind of define what it is, how do we measure it. So again, encourage you to write down notes, take the information as needed. In particular, let's make sure that we are writing down some things so that we can define density. We want to make sure that we know how to measure mass and volume and define each of those. We should already know that. And mathematically calculate density, which is probably our kind of biggest goal that we'll end up being assessed with in this unit. Some of our vocabulary, again, make sure you get these written down: density, mass, volume, and water displacement. Right. So in general, just using the word density is kind of talking about how much mass is in a given space. We use density in everyday language just really to express how closely packed together things are. We can say certain cities, particularly, have very dense population. So you have a lot of people living in a given area. Other places are less dense, so you have fewer people living in a given area. The image on the right shows an idealized way of looking at a couple of images. The one on the left we would say is less dense. The one on the right is more dense. And there's some reasons why different substances tend to have different densities. Part of it has to do with what they're made of. Part of it has to do with the atoms that make it up. Part of it has to do with whether they're solids, liquids, and gases. So different things tend to have different densities, and we can use densities to help identify what an object is. If we looked at the image above me in the video, the one on the left would probably be a gas. The idea that the particles are spread out a little bit further, they don't tend to be connected. They don't necessarily have a certain shape. The one on the right would probably be more of a solid. You can see they're the same sized circles, but they're packed more closely together. So typically gases are less dense, typically solids are more dense, typically liquids maybe somewhere in the middle if we measured all of that. If we relate this to the periodic table, different substances, different elements on the periodic table have different densities. This is a neat graphic. It kind of shows by the height of the bar on there which substances, which elements would be the most dense or which ones would be the least dense. And you can see from just looking at this, the transition metals tend to be the most dense. The low density, however, ones tend to be the smaller ones. These are the ones that kind of have the short stacks on them. These are going to be smaller elements, and interestingly enough, the first two groups, which are metals, and normally we think of metals as being dense, they actually tend to be fairly have low densities to them. As we move across the periodic table, once we get past the transition metals and moving back over to the right-hand side where the non-metals are, we can see that the densities tend to go back down, and these tend to be smaller as well. So it kind of makes sense that at the bottom of the periodic table, these things are more dense because remember that an atom has protons and neutrons. That's giving it some mass. But we've also talked about how as you move across the periodic table from left to right, the radius tends to get smaller and smaller and smaller. So if you think about things being packed together, they do tend to get more and more packed together as you move across to the right. The elements in the blue over here, these would have a larger radius, but they don't necessarily have a lot of stuff in them for the radius. And again, if we think about density being as how packed together they are, these would be pretty low density. So lithium, even though it's a metal, tends to be very light. The other metals, though, the transition metals in particular, tend to be more dense and has to do with their arrangements and how they're just kind of put together. When we calculate density, we need to know a couple of other measurements. So density is a derived measurement. We can't just directly measure density. We need to know two other things. Density is simply mass divided by volume. If we know either of those two things, if we know those two things, we can determine the density. Mass, by definition, we've gone over this earlier, is the amount of matter. We would typically figure that out with a scale or a balance, and we would need to know how much space it's taking up. And the amount of space it takes up can be measured in several different ways depending upon what it is. Before I move on, this is a Greek letter rho. So scientifically speaking, this is typically how the formula for density is written, although in our class we'll usually just use the letter D instead. If we want to measure volume, we can do it in a few ways. If we've just got a liquid, we can just pour it in a graduated cylinder, and we've got our volume calculated. If it's some type of regular solid, particularly a rectangle, we have formulas for that. So mathematically, length times width times height would give us the cubic centimeters If we were measuring in a cubic centimeter, if we were measuring in centimeters, we would get a measurement that was in cubic centimeters because we would multiply those three things together. So length times width times height. And then if we have something that's a little bit weird shaped, irregularly shaped is our proper word, and if it would sink, we could stick it in the water and use what's called water displacement to be able to figure out what the volume of that object is. So in this case, like the piece of wood, we could mathematically figure that one out. One thing about water is it's easy to use because even though we normally wouldn't measure wood in milliliters, we could convert it because 1 milliliter of water is the same as 1 cubic centimeter. So when we put something in water, pretty simple. If we put something in water, the level of the water is going to go up. And if we know the beginning amount of water and we know the end amount of water, if we measure the change in the volume, then that's going to be due to whatever it is that we put in there. So in the picture on the right, in this example, we've got a rock. It's kind of a weird shape. We can't directly measure the volume, but if we put it in the water, if it went from 150 to 210, if I take the math and do the after measurement and before, which is basically the change, 10 minus 150 would give me 60 milliliters, and I would know that that rock had a volume of 60 milliliters or 60 cubic centimeters. Water has a density of 1. In other words, what that means is that if I had 1 gram of water, it's going to take up 1 milliliter of space. Or if I have 1 milliliter of water, it's going to weigh 1 gram. Things that tend to be more dense, in other words, if they had a number bigger than 1, they're going to go to the bottom of the water. Things that have a density of less than 1, 0.9, 0.8, 0.7, they're going to float in the middle. And if something had the exact same density, it would just kind of be suspended and stay in the middle. Heavy things can float because we need to not think about how heavy it is, but what is the density. Something like a boat, the reason it's going to be able to float is because it has a lot of empty space in it. It may have cargo space, a cruise ship may have rooms in it, and most of that is going to be filled by air. Air, being a gas, tends to be has a very low density, and so even though the boat itself is heavy, it takes up so much space that if we measured its density, it would end up being less than 1, which is going to allow it to float. The reason a boat occasionally sinks is because if it gets a hole in it, then that air gets displaced by water, and even though it's the same amount of space, it starts getting heavier and heavier and heavier, and that's what's going to cause it to sink. We know that human beings can float as well. Just a couple practical things about how can you float better, what might cause you to float differently. Remember, if you're going to float, you need to be less dense than water. So one of the ways that we can do something with our body simply is to make our body take up more space. Really, the only way we can do that is to breathe out. When you inhale, you're expanding the size of your lungs. So if you ever find yourself needing to tread water and to float, one of the easiest ways to do that is to kind of inhale and hold your breath in as much as possible. Some animals are able to float a little bit better. Some people are actually able to float a little bit better because of their body composition. If someone has a lot of fat on their body, an animal has a lot of fat on its body, it's going to be able to float more easily because fat is less dense. If you've ever seen oil in water, it tends to go up to the top. And another thing is that salt water tends to be more dense, so it's easier to float in salt water. The image in the bottom here is at the Dead Sea, which is one of the saltiest places on Earth. And the more salt we put in the water, the more dense it becomes, and the easier it is for something to float in it on top of it. Density is a physical property. If we have a substance, it's going to have a density that's consistent all the time. For example, aluminum always, if I have a cubic centimeter of aluminum, it's going to weigh 2.7 grams. If someone gave you a mystery sample or someone was trying to sell you some gold, one of the things that you could do if you had a scale and a graduated cylinder is you could determine to some degree whether or not it was, well, you could determine if it wasn't gold, if the density was wrong, because gold has a specific density, silver has a specific density, and it's not going to change. So if we know 2 of these 3 things, we can calculate the missing value, and we're going to work on some practice problems here in a moment. For example, if I know mass and volume, I can divide them to get density. And the way the triangle works is the idea if I don't know density, I can make a division here between mass and volume. If I didn't know volume, I take the mass and divide by density. And if I didn't know mass, and I'm trying to figure it out, I would just multiply these 2 numbers together to be able to get them. So this is our basic formula that density is mass divided by volume. So if we take density as mass divided by volume and make that into a triangle, we can rearrange it however we need to. You just simply cover up the one that you don't know. For example, if I don't know the mass, then I would multiply those 2 things together. They're side by side, so we would multiply them. When you cover up, if you covered up volume, for example, mass over density, that's going to be the way we would calculate that. So in quick summary, you've got some practice problems to work on, but density is a property of matter. It's a physical property. It effectively takes the measurement of mass and volume and combines them together to tell us how packed together things are. Things that are more dense are going to feel heavier. If they're less dense, they're going to feel lighter. And objects tend to float or sink due to the relative density of them inside of water.